Hello students, this is supposedly the kind of solution I expect from your take-home exam, problem 3. So using Excel and matrix approach to determine the deflections at A, B, C, D, E, and F directly, EI is constant. So since we can use Excel as our aid in analyzing this problem, I think there's no need to explain how I arrive with this stiffnesses for specific members A, B, B, C, C, D, and D, E, as well as E, F, because EI is constant. Then, since we consider all points, the fact that we can use Excel here or your matrix calculator, then we treat each segment of the beam as fixed-ended. So this is the fixed-end moment, 6, 6, counterclockwise at the left, clockwise at the right. Then fixed and force 18 upward, 18 times 2 divided by 2. Then this one 18 times 4 square over 12, so 24, 24 here. Then 18 times 4 over 2, so we have the fixed and force 36. Then CD, there's no loading, so that means fixed and forces, fixed and moment, zeros. Then DE, fixed and moment here is counterclockwise, W, 24 times 5 square over 30, so it will give us 20. And here clockwise, W24 times 5 square over 20, so 30 kilonewton meter. Then at EF, since this is treated fixed-ended, it's like the 25 kilonewton load acts on the fixed support, so it cannot produce moment. But there is a reaction supposedly upward, fixed and force upward, so the nodal load would still be 25 downward. So therefore, we have to consider nodes A, B, C, D up to F. We only consider those nodes or those numbers with corresponding displacements. So 1 and 2, then 3 has no displacement, so that's why it's not included here. 3 is delta B actually. 4 is theta B. 5 and 6 at C, both deflection and rotation. Then at D, both deflection and rotation also. So that is 7 and 8. At E, only rotation, so that's why we have 10. 9 is delta E, so it's 0. And at F, both deflection and rotation, so that's why we have 11 and 12. And these are the displacements. This is the global stiffness matrix. These are the loads, the nodes. Opposite of 18 is negative 18. Opposite of counterclockwise moment is clockwise moment, so that's why negative 6. At B, 6 minus 24 is negative 18, so that's why we have negative 18 here. At C, 36 downward, so negative 36, and opposite to this clockwise moment, counterclockwise positive 24. At D, we have opposite to 18 upward, so 18 downward, negative 18. And opposite of counterclockwise moment is clockwise moment, so negative 20. At E, we only have opposite of clockwise 30, so counterclockwise 30. So that's why we have positive 30 here. And at F, we have downward negative 25 and moment 0. So in your take-home quiz, this should be the solution. And after that, you use Excel or your matrix calculator in obtaining the product of the inverse of this stiffness matrix and this corresponding global stiffness matrix. So since you know already how to prepare the values of each cell here in this 10 by 10 matrix, then I will not also explain to that. So these displacements are obtained as the product of the inverse of this 10 by 10 matrix and this force matrix here. So that's why I present my calculation based on this uh, Excel here. Clip from Excel, I just transfer the values forces here. Then this is the 10 by 10 matrix, and these are the results corresponding uh, displacements. I assume that E is, because EI is constant, I assume it is 100,000 kilonewton meter square so that it's easy to verify the answer. So if we divide this by 100, that's 7.552 mm from any software available. So that's why you have here X is, of course, there's no horizontal load, horizontal displacement, just vertical. So 7.552 mm if you divide that by 100. This one, if you divide this by 100,000, it is negative 3.716 times 10 to the negative 3. Here it is theta B. So if you divide this by 100,000, negative 3.956 times 10 to the negative 3 radians. Then this one, delta C, if you divide this by 100, the shortcut, it will give us negative 13.237 mm, so and so on and so forth. So that verifies the calculations and computations. So these are the forces. Then wait for the specific problem where the calculator can be used here. So 4 by 4, I will present the solution to this without this Excel software. So just the portable calculator which is capable of solving 4 simultaneous equations. So this is the kind of solution that I expect to give you 15 points worth.